This is Geometry Lesson 3.2, Finding the Nth Term. So in this lesson, we're going to look at writing function rules. And a function rule is going to be something that helps you figure out what comes next in a sequence. And I think we're going to be looking only at linear sequences here. So the way that we're going to write our function rule is we're going to have a number by an n followed by another number. That leading term is what we're going to call the change. And then behind that, we're going to call that the zero number or the starting number. Now, I did say that this is going to be mostly linear equations, so hopefully this is kind of familiar. It's basically mx plus b. We're just kind of using some different letters to say how it changes and working backwards to the starting value. Okay? Let's try writing a couple, we're going to use the function rule that's already given to us and then to complete the table. So the first one here, example A, the function rule is given as 4n minus 3. What that tells us is that we are changing by adding 4, adding 4, adding 4. And if we were to go backwards one term, right, subtracting 4 once, that brings us to our 0 term. Okay, so we're adding 4 to move forward, adding 4 to move forward, adding 4 to move forward. We can keep that pattern going by just adding 4, and then adding 4 more, and then adding 4 more. Okay, now this ... means we're going to skip some answers. There's nothing that you need to write there. It just means we're going to skip an answer, skip an answer, skip an answer to get to the 10th answer. Now we could just go plus 4, plus 4, plus 4 a few more times, but I want to show you how we can use the function rule to jump to any answer without having to keep adding 4 and adding 4 and adding 4. And that is we're going to replace the n in the rule with the value that we're looking for. So in this case, that would be 4 times 10 minus 3, right? I'm putting the 10 in for the n of this rule. So 4 times 10 is 40. 40 take away 3, we have 37. And I just wanted to show you quick, if we had chosen to use the calculator to do that, we got the same answer, right? So starting with the 1, we are adding 4, and that's the 5 we see, and that's the 9 we see. My bad, he's kind of off the screen, isn't he? And then that's the 13 we saw, the 17 we figured out, the 21 would have been next. That's our 6th answer. And then 7, 8, 9, 10 gave us the same answer of 37. Let's try another one. We have example B. The rule down below looks like negative 2n plus 5. So again, following my function rule, that means I'm changing by subtracting 2, subtracting 2, subtracting 2. And if we worked backwards to the starting number, the number in front of the 3, it would have been a 5, right? Working backwards, we add 2. Working forwards, we subtract 2, and so on, okay? So negative 1 take away 2 will bring me to negative 3. Take away 2 more brings me to negative 5. Take away 2 more brings me to negative 7. I can continue this pattern, take away 2, take away 2, take away 2, but I want to practice using the function rule. I'm going to substitute the 10 in for the n. So I kept the negative 2 the same. I put 10 in for the n. I kept the plus 5 the same. Negative 2 times 10 is negative 20. Negative 20 plus 5 will give me negative 15. And then I do want to check my answer just to make sure I got that right. So I'm going to just start from negative 7. So I'm at my 6th answer. Negative 7. I'm at my 6th answer. And I'm going to take away 2 to get to my 7th answer, my 8th answer, my 9th answer, and my 10th answer. So whether we keep subtracting 2, keep subtracting 2, keep subtracting 2, or plug it back into the function rule, it looks like we got the same answer. Example B, now we're going to try to write those function rules ourselves, okay? So we're going to look for a pattern, see what comes next. work our way backwards to our 0 answer, and then write our rule from that. So looking from here, from 9 to 13, how does that change? I know that that's going up by 4. 13 to 17, going up by 4. 17 to 21, it looks like my rule is that I'm going up by 4. So I'm going to jump right here where I'm going to write my rule. I'm going to start with 4n because I know that it's increasing by 4, increasing by 4, increasing by 4. Okay? And then I'm going to just keep that pattern going so that I can finish this table here. But now I also need to work backwards to get the 0 number to plug in to finish off my rule. Okay? So I'm going to subtract 4 to work backwards, which brings me to a 5. Because he's a positive 5, I'll write plus 5. So my function rule then is 4n plus 5. Now I really don't want to go plus 4, plus 4, plus 4, plus 4, plus 4 50 times. That's going to take me a minute. So instead I'm going to plug that 50 back in for the n. Four times 50 is 200. 200 plus 5 is 205. And one more of those, we're kind of doing the same thing. Our pattern starts with 7, goes to 2, goes to -3, goes to -8. That looks to me like we are subtracting 5. Subtracting 5. Subtracting 5. So I'm going to keep that pattern going. -5 from -8 brings me to -13. -5 from -13 brings me to -18. Because I am subtracting 5, my rule will start with -5n. Now I need to work backwards to get the number in front of -7 in the pattern. So I'm going to add 5 to work backwards. That will bring me to a positive 12. So I will write plus 12 to finish my rule. And now, again, I don't want to do -5, -5, -5 100 times. I can plug that 100 in for the end of my rule. Okay. -5 times 100 is -500. -500 plus 12 will be -488. Okay, and you can always type these in straight in your calculator. Your order of operations should work just fine if you don't feel confident with your arithmetic. But that is it for these for these examples. Good luck on the exercises, and let me know if you have questions.